This video covers everything we did in class today on Wednesday, October 6th. We're working on Unit 1, Lesson 10. There are going to be two activities covered in this video, Activity 1 and Activity 2. After you finish Activity 1 and Activity 2, you'll have an exit ticket, followed by a study guide for the test that's coming up on Friday. Activity 1 says, if a student uses a ruler like this to measure the length of their foot, which choices would be appropriate measurements? Select all that apply. Be prepared to explain your reasoning. 2 says, here is a scale drawing of an average 7th grade student's foot next to a scale drawing belonging to the person with the largest foot in the world. Estimate the length of the largest foot. Pause this video and give questions 1 and 2 in Activity 10.1 a try. So again, pause and try 10.1. Okay, so if you're watching the video at this point, you should have already attempted 10.1. In question 1, the key idea is that some of these measurements are a bit too detailed to see on a ruler. For example, if we're looking at inches, we can tell the difference between 1 inch, 1 inch and a tenth, 1 inch and 2/10, 3/10. And actually, in this case, it's not divided up by tenths. It's actually split up into 8 groups. But you can see that this is 1.5, and then we've split this into 4 groups. So this here would be about 1.12. But we won't be able to tell precisely a measurement that's more specific than one of these tick marks. For example, if there was a measurement that landed just about here, we would know that it was, somewhere between an inch and an eighth and an inch and 2/8, but we're not going to be able to tell the exact measurement. And so when you see something like 9 and 5/64 inches, it's way too specific. You're never going to be able to get that specific of a measurement. Whereas 9 and 1/4, this right here is 1 and 1/4. We can see fourths on our ruler, so that would be a perfectly acceptable measurement. And it's the same kind of idea for C, D, and E. We can see where, for example, 2.5 centimeters is on the ruler, but we can't see something as specific as 2.7659 centimeters. Those are going to be way too specific. So D is a plausible measurement, but C, E, and B are all just way too specific. Now, 2 says, here's a scale drawing of an average 7th grader's foot next to the scale drawing of a foot belonging to the person with the largest feet in the world. Now in class, we talked about how the average 7th grader's foot is about 10 inches. And so the question is, if the average 7th grader's foot is about 10 inches, how long, what is the length of the largest man in the world's foot? And we can see that the largest man in the world, his foot is about that 10 inches, right? That same 10 inches that we drew here. And maybe about a half a length. Let's see. This orange line I'm using to show about a half of the 10th grader's foot. And that looks about right. Looks like the extra distance on the largest foot in the world is about 5 inches. It's about a half. And so that means that the average 10th grader's foot is about 10 inches, and the largest person in the world's foot is about 15 inches. And we use that estimate by comparing what we know about 7th graders' feet to the scale drawing. Okay, so the real long activity we did in class today was 10.2, same plot, different drawings. And it says, here's a map showing a plot of land in the shape of a right triangle. This is the right triangle here. You can see it's a map of Philly. We've got Arch Street, and the cross street is 17th Street with Ben Franklin Parkway. Now, it says your teacher will assign you a scale to use, and on centimeter graph paper, make a scale drawing of the plot of lands. Make sure to write your scale on your drawing. So if you're home, the scale that I'm going to assign you to use is 1 centimeter equals 10 meters. And this triangle, the true measurements of this triangle are 90 meters and 120 meters. So you might need to pause this video to write these things down because they're going to be important for this activity. Now, on your graph paper, you will be able to draw this blue triangle, 90 meters to 120 meters, using the scale 1 centimeter equals 10 meters. For example, let's say that I wanted to draw 50 meters. If I wanted to draw 50 meters, I know that I would need to use 5 centimeters. Each of these squares is going to be a centimeter. So this right here, 1, 2, 3, 4, 5, would be 5 centimeters, or it would represent 50 meters. This line right here would be 50 meters. So your job is to draw this triangle, 90 meters by 120 meters, on this graph paper here, using the scale 1 centimeter equals 10 meters. So pause this video and give that question a try. Okay, so I'm going to comment on your work, and I'll send you an email if you need to revisit it. I'm not going to go over it in the video, but your scale drawing should represent a triangle that's 90 meters tall and 120 meters wide. To find the area of a triangle, we know that we can use the formula 1/2 base height, and that's of course the same thing as saying 1/2 times base, that dot means times height. You know that your base is 120 and your height is 90. So you should be able to find the area using this formula, 120 times 90 times 1/2. So go ahead and pause the video and answer question 2. Pause the video to answer question 2. Now question 3 says, how many square meters are represented by 1 square centimeter in your drawing? Well, we know that 1 square centimeter in our drawing, this would be our drawing, 1 centimeter by 1 centimeter, that is 1 square centimeter. But in real life, this same drawing, 1 centimeter and 1 centimeter, is actually going to be 10 meters by 10 meters. So what this question is asking is, how many square meters are represented by 1 square centimeter? So this square right here, what is the area? What is the area of this square? You know that the base is 10 and the height is 10. So what's the area of this yellow square? And this yellow square is just what 1 square centimeter represents in the drawing. Pause this video and answer question 3. So you are pausing the video to answer question 3. Okay, so question 4 you won't be able to answer at home because we won't be able to compare our work, but stay tuned and just kind of listen to a summary of the discussion. Other people in class might have had different scales. For example, they might have gotten the scale 1 centimeter. Here, let me draw it over here. They might have gotten the scale 1 centimeter equals 5 meters. And if you had gotten the scale 1 centimeter equals 5 meters, to represent 50 meters, you would have needed 10 centimeters instead of 50, because we multiply both sides times 10. And so that means that your representation of those same 50 meters would be this red line. It would be a lot larger. So notice that when our scale uses 1 centimeter to represent 10 whole meters, we end up with a smaller line. But when our scale uses 1 centimeter to represent only 5 meters, we end up with a larger line because 1 centimeter represents less space. You don't need to write anything down for question 4. That's just some helpful information to know. So your next step for today is to go into today's main folder, and answer the exit ticket, which is going to be in Freckle. After you complete the exit ticket, you are going to head to the study guide and work on the study guide, which we will review tomorrow, either in class or on the video that I post in Schoology. Thanks for watching, guys.